All right, welcome back, everyone, to the deep dive. We're diving into some pretty crucial Java concepts today.
Yeah.
Ones that, you might think, oh, these are basic. But honestly, like having that deep understanding can really set you apart in a senior level interview.
Absolutely.
So we're gonna really dissect type checking and conversions in Java today.
Okay.
And, focusing especially on instanceof and casting.
Yeah. Those are, they seem fundamental, right?
Yeah, totally.
But like you said, look, really mastering them shows that you really understand what's going on underneath the hood.
Totally. And like as a senior dev, you're not just expected to write code that like works, but you're expected to like understand, okay, why am I doing this? What are the potential pitfalls? That good stuff.
So let's imagine we have a scenario here. You have, an InSequence. It's a sequence of integers, pretty basic. But sometimes, like from context or your domain knowledge, that this specific InSequence is actually a digit sequence, which has this really nice method called rest.
Okay.
Which gives you all the digits after the first one.
Yeah.
But you can't just call rest directly on the InSequence reference.
Right. Yeah.
Java's like, no, you got to be a bit more explicit here.
Yeah. Yeah.
You need to tell me what you know about this.
Right. Yeah.
And that's where casting comes into the picture.
Gotcha. Okay.
You're basically saying, hey, compiler, I know, like, based on my knowledge of the code here, that this InSequence, it's actually a digit sequence in this particular instance. So, you do that with parentheses.
Okay.
Like this, you say digit sequence.
Right.
And then, boom, now you can call digits.rest.
Okay.
But the key thing here is that, the rest method, it's specific to the digit sequence. It's not part of the more general InSequence.
Yeah. Right. Okay. So casting's like you're making an assertion based on what you know.
Yeah.
About the code.
About the runtime type. Yeah.
But what if you're wrong?
Oh yeah, that's a great point.
Yeah, like what if that InSequence isn't actually a digit sequence?
Yeah. Then things can get a bit messy.
Oh.
So you try to cast an object to a type. It really, like, fundamentally isn't. You're going to run into a ClassCastException at runtime. And, for senior devs, like, it's not just about avoiding those crashes. It's about, designing systems that are resilient, right? So, like, some unexpected data doesn't bring the whole thing down.
Yeah.
So, for example, trying to cast an InSequence to a string, like, that's never going to work. Right. They're just totally different things, right? Like, there's no inheritance relationship there. The compiler will probably tell you that before you even run the code.
Yeah.
Like you're trying to fit a square peg in a round hole.
Yeah.
But sometimes it's a bit more subtle.
Right?
It's not as obvious.
So what would be like an example of that kind of like trickier situation?
Okay, so let's say you have this InSequence, right? And maybe it was created using like a random number generator. So like it could potentially hold random numbers.
Right.
And then you're like, okay, I'm going to cast this to a random sequence,
All right.
which is, some hypothetical class for random integer sequences.
Right.
Now the compiler, it might let this slide, right?
Yeah.
If it sees that there's like a possibility, like maybe this could work.
Okay.
But then at runtime, if that object is really just a plain old InSequence and not actually a random sequence, boom, you get that ClassCastException.
Oh.
And that's why, you got to be careful with casting, especially in large applications, right?
Yeah, totally.
Where it's not always so clear what type something really is.
Yeah, so you're saying like we gotta be careful. We gotta be precise.
Exactly.
You can't just make assumptions.
Yeah, and that's where the instance of operator comes in.
Okay.
It's like your bodyguard against those nasty ClassCastExceptions.
Okay, I like that analogy.
Yeah, so you can ask at runtime like, hey, is this object an instance of this specific class?
Right.
Or any of its, parents in the inheritance tree, or even interfaces it implements.
Okay, yeah.
And the syntax is pretty simple. It's just object instance of type.
All right.
And it gives you a true or false, a Boolean.
Right.
So it's a good habit to use instance of before you try a cast, especially when you're, writing code that needs to be robust and error resistant.
So it's almost like a double check.
Yeah.
Like making sure that, all right, this actually is what I think it is before I try to like force it into this other type.
Exactly. You're saying, hey, are you really a digit sequence? Okay, then I can treat you like one.
Right, exactly.
Yeah, and it's also important to remember, instance of is null safe.
Oh, totally.
So if the object is null, it's always going to be false.
Oh, okay.
Because a null reference, it can't be an instance of anything.
Right, makes sense.
It's nothing.
Yeah. Okay, so we're doing this instance of check, and then if it's true, then we can do our cast like safely.
Exactly.
But there's also this other way, right? This pattern matching thing.
Oh yeah, that's a really cool feature.
Yeah, I feel like that could really like show off,
Yeah, your Java chops.
Yeah, in an interview, like, hey, I know this modern, elegant way of doing things.
Exactly, because the old way, it was a bit verbose. You had to check the type, cast it, and it was like 2 separate steps.
Yeah.
So Java's like, okay, let's make this a bit smoother. So now you can do it all in one go.
Okay.
You can say if sequence instance of digit sequence digits,
right,
and then open your curly braces, and boom, you can use digits directly in there.
Okay.
So what's happening is if sequence is actually a digit sequence, it automatically gets cast to that type. Okay. And a new variable called digits is created right there inside the if block.
Gotcha.
So it's just a cleaner, more concise way of writing it.
And it's also like more readable, right? It's clear what your intention is.
It just flows better.
Yeah.
And that's something senior devs, we really care about.
Totally.
Making code that's easy to understand and maintain.
So within that if block, then I can just like go to town on digits,
Exactly.
and use all the digit sequence methods. I don't have to do any extra casting.
Yep, you're good to go.
All right, that's super cool. So that's a really nice way to do it. It's more compact. It's more readable,
and it avoids those potential errors of forgetting to cast or casting to the wrong thing.
Exactly. Now I also remember though that there's this thing with the logical OR operator.
Oh, right. Yeah.
Where you can't use the pattern matching instance of with that.
Yeah, that's a bit of a quirk.
Yeah, so can you explain like why that is?
So imagine you try to do something like this, right? You say, if sequence instance of sequence digits digits.rest 100 mad.
Okay.
The compiler's gonna be like, whoa, hold on.
What's going on here?
What's going on here?
Yeah.
Because with the OR operator, the right side of that expression, it might get evaluated even if the left side, the instance of check, is false.
Oh, okay.
So in that case, digits, it wouldn't have been created. It wouldn't have been initialized.
Oh, okay.
And then, you try to call digits.rest. And you're gonna get like a null pointer exception or something.
Yeah.
So the compiler's, it's trying to protect you from those potential errors.
So it's basically like a scope thing, right?
Yeah, exactly.
Like the digits variable is only like really alive and well within that if block, and only if the instance of check passes.
Right. So it's like it's a very specific scope for that variable.
Okay, that makes a lot of sense. Yeah. Now, what about the ternary operator?
Oh yeah, question mark colon.
Yeah, the question mark colon. Can we use pattern matching instance of with that?
Yeah, you can definitely use it there.
Okay.
So for example, you could say double rest value sequence instance of digit sequence digit digits.rest 0 bitty.
Okay.
So if sequence is a digit sequence, it gets cast to digits, and then you get the rest value.
Okay.
But here's the tricky part, right?
Yeah.
It's the scope of digits.
Got it.
It's only within that first part of the expression.
After the question mark.
Right.
So you can't use it in that else part.
Okay, after the colon.
After the colon, right?
Right.
So it's still bound by that instance of check.
Okay, so it's really like tied to that specific part of the expression.
Exactly.
Yeah. Okay, now I also vaguely remember that there's some connection to switch statements.
Oh, right.
In newer versions of Java.
Yeah, so it started as a preview feature.
Okay.
But now you can actually do type patterns within switch statements.
Okay.
It's kind of similar to what we've been talking about. You check the type of an object in a case label.
Right.
And if it matches, it'll automatically get cast to that type within that case block.
Gotcha. So it's another example of Java like moving towards
more expressive and safer ways of handling types.
Right. Okay, so we've covered a lot of ground here.
We have.
With casting, instance of both the traditional way and the pattern matching way.
But now I wanted to shift gears a little bit and talk about interfaces.
Okay.
Because that's another like really fundamental concept in Java.
Yeah, absolutely.
That, as senior engineers, we really got to have a deep understanding of.
Yeah, it's all about designing good architectures,
right?
Building systems that are modular, flexible, maintainable.
Yeah.
So interfaces play a big role in that.
Okay, so let's start with extending interfaces.
Okay, yeah.
Because the notes mentioned, like, okay, we have a channel interface that extends closable.
Right. So when one interface extends another, it's basically creating like a hierarchy of contracts.
Okay.
So the channel interface, it inherits all the methods from closable.
Okay.
And then it can add its own on top of that.
Right.
So any class that implements channel, it has to provide implementations for all the methods in both channel.
Okay.
And closable.
Right. So it's like saying that a channel is a more specialized type.
Yeah,
of closable. And so it has to like fulfill all those requirements from both of those interfaces.
And this is really good for code reuse, right?
Yeah.
You're not duplicating stuff. And it also makes it very clear, what each part of the system is supposed to do.
Right. It's like a very clear is a relationship.
Exactly. It's like, hey, I'm a channel, and by the way, I'm also a closable.
Right. Now, what about situations where a single class needs to like implement multiple interfaces?
Oh, yeah.
That are not necessarily related through extension.
So in Java, a class can actually implement as many interfaces as you want.
Okay.
So it's like it can have multiple personalities.
Okay.
Right? It can wear different hats.
Yeah.
And the notes had this example of a file sequence, right?
Yeah, file sequence, yeah.
Which implements both InSequence and closable. Right, yeah.
So what does that tell us about a file sequence?
So that means that, it can be treated as a sequence of integers.
Right.
But it also has to, like, handle the whole closing thing.
Exactly.
Like releasing resources.
Yeah, it's got to clean up after itself.
Yeah. So it's really like having multiple, like, super types.
Yeah, multiple facets to his personality.
Yeah. Okay, now one thing that I always kind of, like, thought about interfaces was that they're mostly for, like, method signatures. But the notes also mention that you can have constants in interfaces.
Yeah. That's right.
Like, can you elaborate on that a little bit?
So any variable that you declare inside an interface, it's implicitly public, static, and final.
Okay.
So they're basically constants. Yeah. They belong to the interface itself. And you can access them using the interface name.
So like the swing constants example?
Oh, yeah, that's a classic one.
Yeah, with north, south, east, west.
All those directions.
So those are like, named immutable values.
Right, yeah.
That are part of that swing constants contract.
So to access them, you would just say like swing constants.north.
Yeah, exactly. Swing constants.north, swing constants south,
right.
And so on.
Okay, and if you have a class that implements that interface, then technically you could just say north.
Yeah, you could, but it's not always the best practice.
Okay.
Because, you might have multiple interfaces that define constants with the same name.
Right.
And then it can get a bit confusing.
Yeah.
So it's usually better to use enums.
Okay.
For a set of related constants.
Right, and that's also more like type safe.
Yeah, exactly. You get that extra type safety with enums.
Right, okay. And then the last thing about interfaces is that they can't have instance variables.
Right. That's a key point.
Yeah. So why is that?
So an interface, it's all about defining behavior. Right. It's like a contract.
Yeah.
It says, hey, if you implement me, you got to do these things.
Right.
But it doesn't say anything about like the internal data of an object in instance variables. They're all about representing state.
Right.
Like the data that an object holds.
Okay.
And interfaces, they're not concerned with that.
Yeah, they're just like the blueprint, right?
Yeah, it's just the what, not the how.
Okay.
So the classes that implement the interface, they get to decide how to actually store that data.
Right. So it's like a clear separation of concerns.
Exactly.
Yeah. Okay. Well, I feel like we've really covered a lot of really important ground here.
Yeah, I blend deep.
Yeah, we've gone pretty deep into casting, instance of interface extension, implementation.
All that good stuff.
Yeah, and it's clear to me that like, understanding this isn't just about like passing an interview. It's about like writing good code
Yeah, it's about being a good developer
Yeah.
at a senior level.
Yeah, and like you said, building systems that are flexible, maintainable, less prone to errors.
Absolutely. And when you understand these concepts deeply,
Mm-hmm.
you can really start to see how they all fit together,
Yeah.
and how you can use them to solve real world problems.
Yeah. So for everyone out there who's preparing for those tough senior interviews,
Yeah.
Make sure you spend some time really getting comfortable with these concepts.
Practice, practice, practice.
Yeah, practice, play around with them.
Yeah.
And really think about like, okay, why am I doing this?
Mm-hmm.
When would I use this approach versus that approach?
Yeah, and then think about some real world scenarios, where these concepts have come into play.
Right.
Or maybe where, not understanding them led to some problems.
Yeah, yeah.
Because those are the kind of examples that, really show that you get it.
Yeah, and those are the kind of examples that interviewers love to hear.
Exactly. They want to see that you can apply this stuff
right.
in a practical way.
Yeah. Awesome. Well, thanks so much for joining me today on the Deep Dive.
It's been a pleasure.
Yeah, this has been a really, really insightful conversation.
Yeah, I've enjoyed it.
And for all of you listening, keep diving deep, keep learning, and we'll catch you in the next episode.
See you.